Hey everyone, thank you so much for checking out another episode of the Weaviate Podcast. I'm super excited to welcome Dennis Xu, co-founder of Mem. Mem is one of the most exciting note-taking softwares out there, and I think with this latest boom in large language models, GPT-4 and all this kind of knowledge management, like the next generation of note-taking and just how you organize your information, just one of the most exciting applications. And so I'm so excited to hear Dennis's ideas and how you're thinking about these ideas. So firstly, Dennis, thank you so much for joining the Weaviate Podcast.
Thanks so much for having me, Connor.
Awesome. So could we maybe dive in with kind of the founding vision of Mem, like this, what's new with.
Absolutely. Yeah. I mean, so I think, the story goes back pretty far. Back in 2014, actually, my co-founder and I, we were both doing our freshman year internships, right? And we were sitting at a restaurant. And, I pulled out my phone and I said, given all that, given how large our digital footprints are, given all that our phones actually know about us and capture about us, isn't it incredible how little that we can actually leverage that information and that knowledge in order to actually then help us do things in our day-to-day lives? Even as simple things as, remembering things that we wrote down in the past before, which fundamentally is what note-taking is about, right? And that's kind of like what we started with, which is, what is this universal behavior that every single person at some point in their life does, whether they write it in a note or they do it by sending, a text to themselves or whatever that is, to simply help remember things. And that was kind of like the origin and the beginning of a lot of those ideas. And one of the things we imagined is, well, what if you could actually then create the structured representation? We called it the Me API, right? Where, you could carry this identity of you, right, anywhere that you would go. And, essentially compiling notes into knowledge, into the structured knowledge graph, this personalized knowledge graph. And yeah, that's kind of how a lot of the idea began. But one of the things that we've kind of always known is that notes would be where we start. But the vision has always kind of been far bigger than that, right? It's like what we're building at Mem is basically it's a personalized knowledge assistant for every individual, for every team, every organization, and it's now obviously we live in a super interesting time where, it feels like I've waited my whole life for this moment in technology to occur. We've always had, there's always been things that machines have been better at humans at. We've known that for a long time. But those have always, the computation, right? They process information faster. But we've kind of always assumed that there were just, these dumb objects that required instructions and very explicit instructions that had to be programmed by an individual. And now I think we've finally crossed the threshold where machines actually understand human language. And we can talk about the semantics of whether it's just predicting the next token, how much of that is understanding. But I was having a conversation with a friend recently, and he said something that was really interesting, which is, well, if you think about the objective function of a human, it's simply to reproduce. But think about all of the different things that we have developed over time that have nothing to do with reproduction, right? And all of these capabilities, right? And so, regardless of all of that, the premise is now that we have machines that can understand human language, the power of this personal knowledge graph that you can build, this personal assistant that you can build for anyone, is pretty cool.
Yeah, it's super fascinating. I think I first came across Mem when I'd write these like Twitter threads of AI papers, and I'd see someone would comment at Memit to save it to Mem, and that's how I first became aware of this, and seeing how it extends from just a note-taking app to how it connects with other data sources. With Twitter being the example I just gave, but I'm sure you're knowledgeable about all these different data sources that your information can be hooked into, and there's certainly a lot to unpack in the story. I really like that thing you said about the personalized kind of knowledge graph. I like this idea. Like we have this one idea kind of in Weaviate land called ref to vec, which is about how you have a user and then you interacted with these items, and that's how you form an embedding for that user. And similarly,
yep. Mm-hmm.
Yeah, and I can imagine these kind of like pages where, say I create like a biology page and I start saving some things, and then I have this embedding for biology and I hook that up into all these external sources as well. And then it's like personalized.
Yeah. And, I think what you're getting at is like everything that we actually do nowadays is captured in one way or another digitally. And you can create really rich embeddings that represent, the current context. And context really ends up being in almost like every assistive experience, what ends up being the key piece that's missing, right? Like if you knew exactly what I was thinking at any given point in time, it's actually not, ridiculously hard to surface the relevant information at that point to you. But it's just, do we know what you're thinking at any given point in time, right? So yeah, that idea is very interesting.
Yeah, it's so interesting. And so I really kind of, maybe for the sake of the podcast and being entertaining, I want to hop right into this GPT-4 topic. Like, how is this just kind of maybe almost the clickbaity thing? Like, how is this going to change everything?
Yeah, I think, so here's the big thing. I think, I've heard a lot of people talk about how, GPT-4 versus GPT-3, and GPT-3 is kind of this, very vague term at this point because it's gone through, 3 different evolutions, and people have always called it GPT-3. But, the earliest versions of GPT-3 were nowhere near, I guess, like Turbo 3.5 now, or even DaVinci, 2 before that. Right. And I think it's pretty interesting to me. I think there's a lot of use cases where you're not really going to notice that many differences between ChatGPT and GPT-4. I think for a lot of use cases, it feels, it's like slightly better. It's definitely better. It's slightly better, but it's slower, blah, blah, blah. Right. And then there's one thing in particular that, at least we've been experimenting with, that we found, that I think is groundbreaking and is obviously being slept on, is just the ability, for this to write code, and to write incredible sound code that is better than extremely experienced engineers can write, when, it has access to the entire internet's worth of knowledge, and all of that stuff. Right. And so what becomes really interesting, obviously, when you have a system that can write code, right, is then all you need to do is give it an environment in theory. And I think this is why there's a lot of, conversation around safety and all of this stuff, right? Like AGI, and I have opinions on some of those things, but I think what's really interesting is if you can have something that can write amazing code, and then you can give it an environment where it can actually execute that code. Now you actually do have this self-improving system that can, in theory, do anything and learn anything autonomously, right? You just have to kind of give it the right tools, right? So obviously there's been a lot of conversation, a lot of thinking, a lot of, I would say it's still like in the early days. Most of definitely the experiences and the products and a lot of the infrastructure too is in its toy phase still. But clearly people have awoken to the possibility. So I would just say the main thing with GPT-4 for me is the ability to write code. And then I think taking, one step back, the way that I've described kind of this day and age to somebody, because a lot of my friends are like, hey, like I've been hearing about this GPT thing. I'm seeing a lot of it. I don't get it. Like what? It's cool, right? Like there's like, what is it? And the thing that I would say is, you have, when the internet first, really reached scale, it made the cost of moving information effectively approach zero. So the cost of distribution, right? And that's what enabled social media. That's what enabled, blogs and like all kind of like, what people would call like Web 2, right? A lot of that stuff. And I think what has happened is now the cost of transforming information has gone to zero. And that is like, that's really interesting. Obviously, there are so many industries that are purely just about transforming information. So many professions that are about just transforming information. I've heard there's already legal, legal and legal companies and lawyers tend to be the latest to adopt new technology. But a lot of paralegals, junior employees are actually being replaced by this technology, even already today. And you have anything that involves moving, taking like all these ETL pipelines, ELT, anything that involves, previously would have required armies of engineers and engineering teams to both build and maintain. A lot of that is now effectively free, right? So I think we're still grappling with the implications of a lot of what that means and what that will mean. All I know is that I think things are going to, get weird, and we'll see.
Yeah, I definitely want to come back to that kind of like ETL data ingestion topic, but I think that idea, to stay on that idea of how it can write code a little more, it's been absolutely mind-blowing, the ability of it. Like when we had Harrison Chase from LangChain on, we were talking a lot about, and also Bob Van Light, CEO of Weaviate, we were talking about like the way that it could maintain software, like it could see the errors and kind of maintain the software, and just the general idea of, writing some code, executing it, seeing the output, and then chaining that to, keep writing code better. I mean, so, and then I guess kind of one topic I want to come on in that writing code sense is like, so as I've been trying to adopt it in my life, I'm mostly dealing with these big code repositories. So I'm thinking a lot about like, how would the Weaviate code base, which is even bigger than 25,000 tokens, like how do I get it to navigate this kind of thing? And this is where I think a lot of these ideas, like LangChain, Llama Index, on how do you...
Exactly. And I think this is like where embeddings, really plays a role too, right? I think also the whole world is kind of awoken to embeddings over the past 6 months. We've been building, we actually started building on embeddings pipelines before we did actually any generative stuff. And this was back in, December of 2021. And this was, back when the best available generative model was DaVinci 2. And it was at that point where it was like interesting, but not actually useful, reliably useful yet. But the embeddings models were obviously, fascinating, right? Because in many ways it wiped away, years of compounding advantages that many search companies had, right? And that they developed like these, proprietary technology just for search. And then, I think, in a lot of ways, a lot of that is becoming commoditized, right? With embeddings, whether it's search or recommendation systems. I mean, there's obviously still a ton of challenges building, on embeddings with each of those, but
amazing, and
far easier than before.
Yeah, I think so. Obviously, with the Weaviate podcast, the topic of embeddings is like the number one thing I want to talk to you about, and I'm so excited about like.
I figured.
So with to come back into the design of Mem, I'm very curious about like how you think about kind of like chunking up all the units that go into the knowledge management and embedding it.
I mean, there's I think here's the really interesting thing. There's I think currently the primary school of thought, where most people are, is you just have this, what I call like this like blob of vectors, where you have, a vector index, you vectorize any piece of information as long as you can represent it in text, although with multimodal models now, I starting to make an appearance. I think that's going to be really interesting as well. But before we go into that, and then you just dump it all in there, and then you do a nearest neighbor search, right? And then you find those things. And I think that works for a lot of the use cases that we can think about immediately and can think about now, and a lot of like the search use cases that actually already exist in the world that we live in. But what happens is you quickly start, like for any like real use cases that are deeper, you quickly start to run into the limitations of basically just this like one shot nearest neighbors, like, that's what I get, right? And you run into that pretty quickly. And I think one of the things that we realized, and this is essentially like, how we think about building our infrastructure, differently, is embeddings are a key piece of the puzzle. But ultimately you also do need structured knowledge underlying it. So it's like you have embeddings that overlay, in our case, it's a structured knowledge graph, right? That we also use language models to build. Right. So it's kind of like, imagine this, database, this actual database, like, a SQL database that you're reading and writing to, right? Reading from and writing to. And then you layer on embeddings on top of that. And now you can do things instead of just like these one-shot, find me, the nearest neighbors. You can actually do deterministic, multi-hop queries that require knowledge of, multiple different things all at the same time. A lot of the things that, I think, things like LangChain, right, also like thinks about, right? But if you think about, and I think this is all like, developing, but if you think about something like LangChain, obviously one of the issues with it is because everything runs sequentially, it's expensive, but I think that's, going to become less and less of an issue. But latency wise, it's expensive, right? But imagine if you could actually convert a user input, whatever that is, right, into a set of deterministic graph reads, right, or database reads that we know are fast, right, and retrieve information that way, and then you blend that actually with like a hybrid index using embeddings. I think that's a lot of where the world will actually head long term.
Yeah, that idea of like question decomposition, like are follow-up questions needed? I don't know if I'm going to remember this off the top of my head, but it's like, did Einstein use a laptop? I don't know if it's Einstein, but like, So you break it into the two questions to assemble it. And and this kind of, in the beginning of, as I was listening, I thought we were kind of getting into like the adding structure to vector search. And this topic I think is so fascinating, especially when you're adding the large language model controller on top of this. A lot of kind of Weaviate and the vector databases having support for the symbolic filters as well as the HNSW, the vector index, and like things like in our 118, Edian talked about the bitmap index to speed this up and all these kind of things. And
so all these different data structures, right? That involve embeddings, but it's not just this like single flat blob.
And so I'm so curious about this. Actually, something I'm talking with Harrison about privately is like, how do the large language models interface with these symbolic filters? Have you thought about this?
I mean, so I think this is actually why the fact that it can write code, this is really, and write accurate code, really comes into play, right? Because now you can actually imagine you define a data structure, you define a certain knowledge graph. Then you can have the language models, you can teach the language models, right, so to speak, to know how to interface with it and to know how to query from it and to know how to write to it. And you kind of take that whole process that would have been, teams of engineers for each pipeline and each transformation before, into just like, hey.
So when ChatGPT first came out, Bob had showed me this thing. He shows me his prompt sequence and he's having it write JSON, like it populates the JSON dictionary. So it's compatible to the next API call, and all that was so fascinating. So I think that was a really great top coverage of like the GPT-4. And I really want to kind of transition to this next topic that's a pretty big one, which is the kind of fine-tuning models versus zero-shot debate. And I'm curious, especially with...
So my take on this has been pretty... So here's my take. I think it's clear we're at some point in the S-curve of the capabilities of these language models. I really don't know where we are on the S-curve. Are we near the end? Are we, towards the beginning? If I had to guess, I would say there's no reason to believe that we're anywhere close to the top of it, and that we're probably likely very much still in like the steepest part, right? And I think when we are in that scenario, and if we just play back what has happened over the last 12 to 18 months, and we assume that things will continue in that way, then what's happening is every 6 months, literally every 6 months, there is a step change in capabilities. And so depending on what you're fine-tuning a model for, my opinion is, if you're fine-tuning a model to improve its general capabilities, with some piece, of your own data or whatever that is, I think that's totally not worth it right now. Because I think what's going to happen is the next model is going to come out. It's not only going to be cheaper, it's going to be way faster, right? And it's going to be way better. And all of the time and effort you spent in actually figuring out how to fine-tune that model will go to waste. Except, and I think it's an important question to ask. Like, what will not change? And this is really, once we do get to the top of the S curve and progress, slows, when we no longer have a new state of the art every 6 months, it takes longer. Then at that point, I think fine tuning to squeeze the additional 20 or 30%, out of these models becomes actually really useful. And the important question to ask, right, is like, what do you need by that point in time? Like, what is the thing you needed to what is the asset you needed to build over the course of that time in order to be able to do that? And obviously, it comes down to, one way or another, some form of data, right? And, even that's obviously, it's a loaded term in terms of like how what is actually useful data, what is not. But, depending on how you define it, at the end of the day, it's the data is useful. The actual time spent in figuring out how to tune these models, or even taking off the shelf open source model to, try to, do something with that to squeeze whether it's latency or performance out of it, I think a lot of the time doesn't actually make sense. I think the difference is, if you take something like a llama, with alpaca, right? I don't know if you saw that came out of Stanford. Obviously, that's very interesting because now you can have things that actually just purely run on the edge, right? Run exclusively on your phone, and that unlocks a whole new set of capabilities that previously wasn't possible, right? But if what you're trying to do is replicate a set of capabilities, I think at least we shy away from fine tuning for that purpose. We do actually do a lot of fine tuning, but that's primarily to make. The reason we do it is to basically get a smaller model to do the job of a larger model at lower latencies, and that will just obviously that data set continues to scale as new models as models improve. So.
Yeah, I thought you said a lot of interesting ideas. I think I really like that S curve thing you described with his step function of his doubling every 6 months. It doesn't make sense to put the effort into it. And Bob, sorry to be referencing you so much in this podcast, but he was recently on Cohere's Twitter. They had a talk where he said that basically he thinks that like 80% of these cases, the zero shot model combined in a hybrid search with like BM25 lexical search, that will cover most of these search cases.
Totally. Yeah. Mm-hmm.
And I completely agree with you. But I really want to there are two more topics that you mentioned that I think are so interesting. The llama alpaca thing, where it's like, it is related to the next topic of distillation, where you're trying to get the large model compressed into a smaller model. But I think the reason the alpaca thing is so exciting is because people are like running it on their phones, right? Like,
like literally running it on their phones. Yeah.
And it's like the idea of, I think when GPT when DaVinci 3 came out, it was something like 2 cents per. I don't know the exact pricing. Like
it was more. It was 6 cents per 1,000.
Yeah, it was pretty expensive to generate a lot of text. So the thinking was like, you got to be so careful about how you do it. But now, as it's trending towards zero, it's like these language models could have like these massive conversations with themselves. And as I think about Mem, I think about this idea of I create a workspace where I put everything I know about contrastive representation learning, and then I just have the language models talk to each other about like sample a paragraph,
and then build new knowledge over time. And yeah, exactly, totally. Yeah.
Yeah, and that idea I think is incredible. So I do want to come back to the distillation thing. Maybe one topic to begin is I'm very curious about these kind of like ranking models. So like the large language model could, of course, rank these documents with very high precision. Like if you have the query and then you have the top 10, it could give you a really great ranking. It is maybe, I don't know if it's like prying too much into exactly how the sausage is made, but like what kind of tasks are you thinking of distilling from large language models?
Yeah. So there's that's one of them. What you just mentioned. Historically, I think in search it's been called like a cross encoder, and I think there's still a lot of value in cross encoders, but you can actually spin up like a purpose-built cross encoder really easily, actually using kind of like a smaller one of these models, right? And then it returns the log probs. You can do interesting kind of math on top of that. A lot of interesting things there, but there's a lot of things where I'll give you one example. Someone says something to their assistant, right, to their Mem assistant, like, hey, do this for me, or XYZ. But it's kind of, if we think about the assistant like as a person, it's kind of unpredictable what you say to a person, and what you say might have different intents sometimes. Even within, this is a huge problem within search, obviously, like search intent. Like, is this a keyword based intent, right? Or is this like, hey, is this a vector intent? And then you like, rank different things differently. Maybe you even, and this is a lot of our explorations is, what if you could create dynamic UIs, right? Because depending on what the person is asking you, depending on what the person is doing, there's actually totally a different representation of the information that is useful and valuable. But being able to even just like classify the intent of a message, let's say, obviously you use the most use GPT-4 on that, and it's going to get it right, like almost every time, assuming you also give it enough context and all of that stuff. But it's slow. It's expensive. Can you actually really run it on every query, right? And so when you have a task like that usually screams, okay, fine tune is actually valuable, right? Particularly when latency and or cost is the issue, and you're okay with causing brain damage to the language model. And being okay with it forgetting everything else and only being able to do this thing, right? Because then you can take a much, much smaller model to basically just do that one specific task, right? And then there's also like ways where you can use those models to generate training data for the smaller models, and it gets really meta. But
yeah, that last one's my absolute favorite idea. I mean, when you said the brain damage thing, that interrupted I love that topic so much that like, because when you fine tune it, this like catastrophic forgetting, how the robustness of it is gone now. And that one's
but it's very good at one thing.
I do want to stay on the ranking thing just a little. There's one question I have for you, especially as product focus with the Mem thing is this latency constraint, and how you're thinking about it, because the cross encoder is really slow compared to vector.
Yeah. Well, I think there's a lot of things. I think a lot of the innovation that's going to happen over the next year is going to be on the UX side. Internally we call this like AI UX, which obviously what that means. But it's to give you one naive example, you look at what Bing does, right? Where you type something in and it's showing you some of the work that it's doing, right? I also saw this like in the Stripe LLM, like for their documentation thing. They did some really interesting kind of like front end animations where first they would, they actually mirrored the steps of what happens, right? First they would retrieve a list of documents. They would show you those documents first. And then when the answer would actually come in, it would push those documents down. And as it kind of tricks you into thinking, oh, actually, this is fast. right? Because something is happening all the time. And I think there's a lot of those tricks you can play, kind of there. And then there's separately, and this is where I think, really having a structured knowledge graph, in our case, comes into play. There's if you think about most of what makes search fast, right? And search indexes, it's pre-processing. So if you actually have the data in a structured way such that you can pre-process it, into useful indices, that's another way to make sure that certain things that you need to be fast are fast. So.
Yeah, that little the knowledge graph topic is a funny one because with Weaviate, it's not like a RDF technology with these tuples.
Yep.
So
I'd
rather talk about HSW, but that is very interesting.
Yeah.
The knowledge graph, does Mem use things like Neo for Java or like Tiger Graph, those kind of things as well?
No, we actually just we build all of it on top of Postgres.
Fascinating. And I also saw this thing with Llama Index. They call it like GraphGPT, where you could just kind of do like one query. So it's like a client side index. Yeah, like take 1,000 search results and now build a knowledge graph in memory, kind of.
Yeah.
Super cool. So maybe pivoting topics a bit. I'm very curious about earlier we mentioned this idea of ETL, data ingestion, to the kind of database part of it. And I'm really curious about I find this like Memit Twitter thing to be such a fascinating integration with how you flow data from Twitter into your knowledge management. And then, so I'm very curious, obviously OpenAI's Whisper has unlocked like a massive ETL. Now people can take YouTube videos, podcasts, and just, do it like that. And then GPT-4, so I'm also talking with Brian from Unstructured about hopefully getting him on the podcast as well. And GPT-4, the ability of it to do OCR, right?
Images, yeah. Well, I wouldn't even call that OCR, because it's at least the way I think about OCR is it just gives you kind of like a snapshot representation back, right? This is kind of it's more like actually it's as if like a human could read the thing, and then you could ask questions based on it, and it just works kind of through this like language model, right? It's the idea of multimodal, like the encoder being able to actually create a representation that is shared between text and images and audio and video. Because if you think about kind of like what people are doing today, this is another thing that I think is going to become obsolete pretty quickly with Whisper, is people are doing that on YouTube videos, right? And it makes sense, but you end up losing so much information because you capture none of the visuals, right? And so much of YouTube videos is the visuals. So, you could transcribe, and then you could try to stitch together the frames, right, from, the actual visuals. But if you could actually just go directly from an MP4 file format into the embedding that actually is in the same space as, your text embeddings, that's where things get really, really cool. And obviously I think that's the future, right? So.
Yeah, I think we just saw Runway's, is it called Gen 2? I'm sorry if I messed up the name, but this video generation, generally the idea of processing videos. So my kind of funny story with this is when I first started doing deep learning, I was a basketball player, come into grad school after basketball and after a failed basketball career. And so I was like, okay, how do I build a deep learning software app for basketball? And I had this idea well, you could probably extract all the highlights from the games using like convolutional networks. But the problem with that, one problem of it, quite a few problems, but like the image data, video data, it's so high dimensional. The idea of like compressing a minute video into a, let's say 1,500 dimensional vector. Do you think that kind of like we'll need to be more clever about how we're doing it?
I think that's an issue. So one of the things I learned about, maybe this was Llama or maybe this was something else. maybe it was Llama, but I think one of like the fundamental innovations was it made it, uh, it turned it from, 16-bit, um, uh, like values, right, per vector to 4-bit values, right? And so it changed kind of like the the granularity of what could be represented to basically just like 8 values, right?
Mm-hmm.
Between -1 and 1. And that's really how they managed to get something so small. And yet it kind of keeps a lot of the performance. So I think there's some really interesting, kind of compression techniques that we're just at like the very beginning of discovering. So, um, yeah, I have a feeling we'll be able to get to that pretty soon.
Yeah, it's fascinating. I love that you brought that up. That one of the big new features of Weaviate in 1.18 is adding product quantization, where, like you say, we quantize the vector values from 32 bits down. Or, well,
Exactly. Yeah.
yeah, there's like a couple parts to it, but I think something about quantization. There's kind of like two. At first, there was this thing called binary passage retrieval, where you sort of optimize the contrastive models with that tan H activation, so it's kind of 0, 1
Mm-hmm.
naturally, and then you have this kind of binary vector that's longer but captures information. I think like quantization aware training is another thing that hasn't been realized as much, because if you put it in, like, instead of producing the vectors and now we're going to run k-means tile encoder on the vectors, maybe if you put that into the optimization, it's like one of these interesting kind of, yeah,
Mm-hmm.
fine tuning. Maybe there's something to like a hierarchical structure, all this kind of these. Yeah,
Yeah.
it's
Yeah.
like
Yeah.
this kind of idea of how do we, like, one of my favorite topics in Weaviate vector database is like, how do you have a, like, we've done like a billion scale thing with like, like Sphere, which is kind of like copying the internet and doing that kind of
Yep.
thing. But yeah, the videos and all that. So maybe kind of even continuing on the kind of multimodal, I guess, I don't know if this topic is too out there for these kind of things, but like, are you interested in these recent advances in robotics and say things like SayCan, RT1? Do you think that will have some kind of role in this as well?
I've been loosely following it, but honestly, I haven't been closely following enough to be able to say anything insightful.
Yeah, sorry, I think that was maybe too tangential of a topic. I actually, one thing I think is really interesting with the knowledge management
Yeah.
thing is like the biomedical thing. Let's actually pivot into that topic. So,
Yeah.
like,
Yeah.
I think these kind of knowledge graphs, like this idea of having structure and unstructured, like just these, like, drug, protein, drug, like
Mm-hmm.
gene
Mm-hmm.
protein interactions, and this kind of graph structure. I think it's the one example of a citation is there's this paper called Prime KG from Harvard, from the biomedical informatics, and like, if people are out there are looking for like an example of what I'm talking about, Prime KG is like the best one I know of, and it's like this kind of way, like, I wonder if, like, with this knowledge management software like Mem, do you think you would have like your genome, your proteome in like your note taking software?
I mean, that's basically that's basically the vision, right? Which is, really we started with notes, and I think over the course of this year, it's going to become pretty clear to people as with some of the new releases that we have coming out that um, like notes are just kind of one component of the type of information that you can capture. And so, we're building a ton of uh, pipelines, right? From like manual data syncing, automatic data syncing of, your emails to, your calendar, like Slack messages, all of that stuff, right? To the one time, hey, I have this PDF, I have this video, I have this thing, kind of like drag and drop in, right, into that. So
Mm-hmm.
really, yeah, the idea is how do we create this universal knowledge graph that represents your entire world of information? And then how do we give you the power of actually being able to hold that in your hands, right? Because I think if you think about it in the past, that's been held in the hands of advertisers who then use that to target us with ads, right? But if you could carry around, one thing that I think this is on our blog too that we've thought about is, you can imagine you sign into Netflix or Newflix, right, with Mem, in 2024, and your experience is automatically just personalized for you. right? And today you sign in with, whatever, you sign in with Google, you sign in with all of that stuff, and, nothing happens. You just manage to sign in. But if we could actually build that personal knowledge graph, then it becomes really interesting. So,
yeah, I think that's exactly what you've unlocked with Mem, and this kind of like you have an embedding of you that you take everywhere that comes from all sorts of things. Like me from the YouTube videos I like are now synced up with the Amazon things I'm buying, and
yeah.
But I'm also very curious, like how you think about like privacy preserving AI.
Yep. Mm-hmm.
Like, do you use things like federated learning? Do these kind of topics come up?
I mean, I think it's one of those things that obviously we're super aware of on at least kind of the research side. I think the obviously the topic is super fascinating, right? Like being able to actually, run inference on encrypted data, right, would be kind of the dream. Unfortunately, it's not really possible right now. I think everything that it's all basically at the viability level of being research projects, right? So eventually, I think that is where the world is going to head, though. Whether it happens in 2025, 2030, 2035, that's to be determined. But
yeah, amazing. Well, Dennis, thank you so much for this tour of these technical topics. That you're so knowledgeable about this, and this was such a fun conversation. Maybe to kind of wrap things up, could you talk about like kind of your experience founding this company? Like, how's it been? It's super successful and all that. And
well, I mean, I feel like we're at just the very beginning of the journey. I mean, especially given what the kind of the vision is for the end product, if there even is this idea of an end product, right? But I think it's been, I would say one of the things that's been really interesting for us is from the very beginning, we kind of knew that this was the vision, this idea of, how do I build this like personalized knowledge graph that I can take with me anywhere? And I think when you have that, in mind at the very beginning, I think it's allowed us to be a lot more, I think, patient, right, and make certain investments that, for example, in the knowledge graph, right, because that's one of those things where actually building this structured knowledge graph that and then teaching language models to know how to interact with it is quite the build, right? It's very complex. Working with a lot of evolving technologies kind of all at the same time. But having, just knowing that, hey, we have to do it because this is why we started the company. This is why we're doing it. I think has been, one of those things that have, made us pretty unique in terms of how I think most startups operate. So that's been, it's been a really interesting part of the journey. Obviously, in the middle, it's been, around 3 years so far. In the middle of the journey is when GPT-3 really became a thing. And it totally, I still remember this happy hour that we had, and this was during COVID, and we had these virtual happy hours. And one of them was just like when the first, Da Vinci 1 first came out, and we just like sat on, in the playground, just playing with it, because I got access to it. We're like, oh, this is kind of interesting. This is really cool. And just seeing this evolution and this revolution happen over the course, like of this company developing and realizing kind of just how much of an unlock it is for a lot of the things that we were doing, has truly been a sight to behold, right? So, I couldn't be more exciting to be building what we're building right now. So.
Amazing. Yeah. And I'm also so excited to see what you're building. And Dennis, thank you so much for joining the Weaviate Podcast and contributing all this knowledge. It's been so interesting to be talking with you. So thank you so much.
Thank you.